My name is Adrian Trujillo, and this is my Lab 2 projectile motion for Physics 2211. The purpose of this lab was to observe how drag affects projectile motion of an object and compare the observed and predicted models. Some fundamental physics principles that were used are Newton's second law, which says force is directly proportional to its mass and acceleration. Drag force, which is the force placed upon a system by its surroundings, which in this case are air, and gravitational force, which is the force two objects have on each other. Um, in this case, the system was a whiteboard eraser, and the surrounding was everything else. Some models and formulas are here in the net force formula, the drag formula, position update formula, and velocity update formula. This is a procedure. First, we set up a meter stick to use it as a calibration stick. Then we recorded a video of an eraser being thrown from one side of the frame to another. We then uploaded the video to a tracker and tracked the position of the eraser as it traveled. Then we constructed a computational model in GlowScript using the fundamental physics principles. Lastly, we created a graph to compare the models in Excel. This is the tracker video, or this is the video of the eraser being thrown. Here are some of the initial conditions. The video was in 30 frames per second. The initial position was set at 0, 0, 0, and because it was easier. And this is the initial velocity. Oops. This is the initial velocity, which was found by doing change in position over change in time. This is the computational coding of the GlowScript. The mass was set at 0.0356, which was the mass of the eraser. The position was set at 0, 0, 0. The ball velocity, as shown earlier. First, B, which is drag, was set at 0, but then it was changed to 0.05, which included the drag. And then everything else on the right, such as F grav and F drag, were used to find F net. And then the fundamental principle update, position update, and velocity update were used. Yeah. This was the GlowScript result with no drag. This was a GlowScript result with drag, as you could see. Looking at the difference, you can't really tell here, but the GlowScript with drag went lower than the GlowScript without drag. Here you can tell better. To the left, first we have the experimental model from the tracker. As you can see, the X is almost constant, and the Y is going down in a parabola shape. Here you can see that with drag, or that's supposed to say without drag. Without drag is the blue, where it goes the highest, or it goes the highest and furthest, or not furthest, but it goes the highest because there's no drag. And the other two are with drag and, well, air resistance and everything. They don't go as high, as you can see. Some possible errors were that drag was not found through trial and error, It was found through trial and error and not calculated. You had to, do it very slowly. And also for the tracker, you had to individually click, which led to human error. What does this mean? The model with drag predicts the terminal velocity with the slope getting gradually smaller. As you could see, this was with drag on the right here. And as you can see, the velocity is going down and getting gradually smaller as it reaches zero, or here it goes past zero, but as it goes down. What if the ball was thrown straight up? The object was thrown straight up. The time it would take to reach the starting Y position would take longer because it would go higher. So yeah, the time it would take to hit the ground would go up. Yeah, it would take longer because it has to go higher since it doesn't go across in the X. Yep.